Your business has recorded millions of sales. Now the questions begin. How did coffee do in the West last spring? Which region is slipping? To answer these fast, we stop thinking in rows and start thinking in a cube. This is a data cube. Every little block is one fact. The sales for a single product in a single time period in a single region. Stack them all up, and the whole business becomes a solid you can turn in your hands. This kind of exploring, summarizing, comparing, viewing data from every angle is called OLAP, Online Analytical Processing. It runs on the warehouse we built from the star schema. Over the next few minutes, we'll learn to spin this cube, cut it, and squeeze it until it answers anything. First, the vocabulary, and it is the whole game. The three edges of the cube are its dimensions, the ways we slice the world. Product runs along one edge, time runs up, region runs back into the depth. Now look inside a single block. It sits at one product, one time, one region. That address is its coordinates. And the value it holds, the number we actually care about, is called the measure. Here, the measure is sales. So keep these two words apart, because everything hangs on them. A dimension is an axis you group by, the labels. A measure is the number you aggregate, what you sum, or average, or count. Dimensions describe, measures get crunched. Our first operation is the slice. The idea is simple. Fix one single dimension to one value and keep everything else. Let's fix region to west, the whole front layer of the cube. Region no longer varies, it's pinned. So the three-dimensional cube collapses to a two-dimensional plane. Just product against time for the west. A slice always drops you by exactly one dimension. And there is the plane, laid flat as a table you can read at a glance. Products down the side, quarters across the top, and the sales for the west in every cell. 20,000 of coffee in the first quarter, right there. Next, the dice. People mix this up with slice, so hold the difference tight. A slice fixes exactly one dimension. A dice restricts several dimensions at once. You pick a little box inside the cube. Say we want just tea and coffee. In the first two quarters, in the west and north, three dimensions, each trimmed to a subrange. What survives is a smaller cube, a 2 by 2 by 2 block sitting inside the big one. Notice, every dimension is still here. The cube didn't lose a dimension the way a slice does. It just got smaller on several of them. That's the tell. Slice cuts to a plane. Dice keeps a cube. Peel the subcube into its two layers, west and north. And every cell is one of our facts. 8 little numbers in all. Add them for the total in that little box. West gives 10, 12, 20, 22, 64. North gives 6, 7, 15, 16, 44. Together, 108. That is the dice, answered. Slicing and dicing filter the cube. The next pair changes its level of detail. Inside each dimension lies a concept hierarchy, an ordered ladder from fine to coarse. For time, day, rolls into month, into quarter, into year. Every day maps to exactly 1 month. Roll up means climb that ladder. Aggregate up to a coarser level. Days become months. The view gets smaller, with fewer, chunkier rows. Drill down is the exact reverse. Descend to finer detail, from a year back down to its months. Let's roll up for real and watch the arithmetic. Here are 3 January days for one store. Sales and number of transactions each day. Roll them up to the month. Sum the sales, 10 plus 15 plus 20,000, 45,000. Sum the transactions, 50, 60, 40, 150. 3 fine rows became one coarse row. And here is the crucial point for later. We rolled up just by summing. Sum is the friendliest kind of measure. We'll come back to exactly why in a moment. One more move, And it's the most literal of all, the pivot, also called rotate. Remember pivoting a table, turning row labels into columns? On a cube, it's the same thought in 3 dimensions. Reorient it. So a different dimension faces you. Watch it turn. A moment ago, product faced us across the front. Now we swing the cube, so region comes forward instead. The numbers inside never change. Not one of them. Only our viewpoint does. Pivot rearranges how the same data is presented. That's the difference worth keeping. Slice and dice throw data away by filtering. Roll up and drill down change the level of summary. Pivot throws nothing away and summarizes nothing. It just spins the same cube to a new face. Now the deep question, and it decides what a warehouse can pre-compute. When we roll up, we combine small groups into a big one. The measure decides whether that's even allowed. Measures come in 3 flavors. Additive measures add up cleanly over every dimension. Sum, count, max and min are the classics. A yearly total is just the sum of monthly totals. The overall maximum is the max of the monthly maxima. These are the ones warehouse love to store. Semi-additive measures add over some dimensions but not over time. A stock level or a bank balances. You can add balances across accounts, but adding January's balance to February's is nonsense. You'd want the latest or an average instead. And non-additive measures resist summing altogether. Averages, ratios, medians, counts of distinct customers. You simply cannot add the subresults and get the right answer. Let me prove that. Because it's the trap everyone falls into. The honest average sale for January is total sales over total transactions. 45,000 over 150, exactly 300 rupees. But if you naively average the 3 daily averages, 200, 250, 500, you get 316.7. That is wrong. The busy day with tiny sales and the quiet day with a huge sale don't carry equal weight. Average of averages fails. Here's the fix analysts actually use. Don't store the average. Store its additive ingredients, the sum and the count, for each group. Then the average at any level is the total sum over the total count divided only at the very end. Rebuilt from additive parts, an average like this is called algebraic, and it comes out exactly right. If all this feels abstract, here's the reassuring part. Every cube operation is just plain SQL on the warehouse tables. The cube is a way of thinking. The database does the work. A slice is a where clause. Filter region to west, done. A roll-up is a group by at a coarser level. Group by month, and the sales sum up automatically. And a dice is a where with several conditions, one per trimmed dimension. SQL even has the cube built in. Group by rollup gives you running subtotals up one hierarchy. And group by cube computes every combination of subtotals at once, by region, by product, by both, and the grand total, precisely the pre-aggregated views OLAP thrives on. Your turn. Pause the video here. You want the total sales for each region, across all products and all time periods. Which single operation gives you that? Think it through before I answer. It's a roll-up. You aggregate the product and time dimensions all the way to their top level, leaving region alone. Slice and dice would only filter. They'd never crush products and quarters into a single total. Rolling both up is what collapses the cube to one number per region. Add every product and quarter within each region, and out come 3 numbers. West, 124. North, 84. East, 57. Sum those and you'd get the grand total, 265. The single block the whole cube rolls up to. Trap 1. Slice versus dice. A slice fixes exactly one dimension and drops you to a plane. A dice restricts several dimensions and keeps a smaller cube. One dimension versus many. That's the whole difference. Trap 2. Which way is up? Roll-up aggregates to a coarser level. Fewer, bigger cells. Drill down goes finer. More, smaller cells. Roll-up summarizes. Drill down opens up the detail. Trap 3. Assuming everything sums. You cannot add up averages, ratios, or medians and expect the truth. Only additive measures like sum and count combine freely. For an average, keep the sum and count and divide at the end. Trap 4. OLAP is not OLTP. OLAP is read-heavy analysis over history, the cube. OLTP is the operational database handling live transactions, one row at a time. Different jobs, different systems. And Trap 5. The cube is a model, not necessarily a thing on disk. Sometimes it's materialized as stored aggregates. Sometimes it's computed on the fly from the tables. The cube is how we think, not always how it's stored. Let's lock it all in. A data cube models your facts along dimensions you group by, with a measure sitting in every cell. You filter and turn it with slice. Fix one dimension, dice, restrict several, and pivot, rotate to a new face. You change its level of detail with roll-up, aggregate up a hierarchy, and drill down, descend back to the fine grain. And you respect the measures. Sums and counts combine freely, but averages and medians never just add. Keep the sum and the count and divide last. Master those, and any cube will answer to you.